What are topics we discussed in last class?
Links, error detection, framing.
Okay. Okay, till internet checking algorithm, till that we have discussed, I think so. Okay, I will share the screen. We will continue class. Yeah, my screen is visible. Yeah, screen is visible.
Yes, sir.
Okay, okay. Till that we have discussed in last class about internet checksum algorithm. Till that we have discussed. Next we are going to discuss about the CRC, cyclic redundancy check. Cyclic redundancy check. In the sense we are going to detect this is also one type of error detection technique, which is at the time of transmitting the data, if by using the CRC technique, the error can be detected. Okay, the reduce the number of extra bits and maximize the production. This is the main usage of CRC, means reduce the number of bits, extra bits. If I am sending the data of 7 bits, means extra bits, if a carry bit or additional bits is there, means that will be reduced by using the CRC. And then maximum production between the sender and receiver will be performed in the CRC. Okay, here by using in this diagram, in this example, see CRC calculation can be done. See here, 100111001. This is the value which is used as a input as a dividing process. CRC means we are on to dividend value plus divisor value. Dividend value is 1001. 10011010. This is the dividend value, and then this divisor value is 1101. Based upon that, we want to calculate the divide the particular divisor, that is the generator is assigned as a divisor, and then the particular dividend value is assigned as a message. Okay, if you are dividing means based upon the normal division, based upon the you want to divide, finally the remainder will be coming as a CRC value, means by the remainder will be coming as a CRC. Based upon the CRC value will be used as a another type of process. Okay, otherwise we will quotient will be generated. By using the quotient value will be different. By using the dividend value, dividend will be added the remainder value by using that. We want to calculate another dividing process will be done in the finally the remainder value will be 0 only. The error detection technique will be done successfully. Okay, this is an example of CRC, how that the CRC is performed by using the values, zeros and ones values, by using the dividend and dividend value. Okay, here let m of small x be a message of polynomial, and c of x means is a generator. We will decide as a divisor. Okay, m of x is a message, means we will assign as a polynomial value, and we can assign as a dividend. Okay, we are dividing, say let m of x divided by c of x, dividend divided by divisor. Leave the remainder is of 0. Want to the value will be remainder will be 0. Okay, here m of x will be sent and m of x will be received. So we have the m of x equal to m of x plus e of x. E of x means that quotient value or we can be assigned as a remainder value. Okay, here the receiver computes m of x divided by c of x. If the remainder is non-zero, then the error has occurred. Non-zero means what? If the remainder value is either except the 0, it has the error has occurred. If it is a 0, remainder is 0, means the error, there is no error at the time of transmission. By using the CRC value, the error has detected. Okay, the only thing the sender and receiver should know is c of x. C of x means that is a generator value, that is a divisor value. Okay, the polynomial arithmetic module 2, based upon that dividend by the divisor. Dividend I already know. No. Dividend or divisor divided by the divisor. Polynomial C of x. If B of x is higher degree than the C of x. Higher degree means what? Based upon the polynomial value. If it is a higher power value is higher means we can't be able to divide the particular value. So the B of x will be compared to value M of x, it will be less than. Okay. Let M of x be a frame with M bits and generator polynomial have less than M bits, say equal to R. R means that remainder value. That is equivalent to remainder value. Where R be the degree of C of x. See, degree means what? Remainder value. Where R depend R 0 bits. R 0 bit to the lower order end of the frame. So now it contains M plus R. M plus R means total bits is M is assigned as a dividend value, and then R. R means whatever remainder is coming that will be added corresponding to the polynomial value. Okay. Here the divide the bits string corresponding to x of power R, M of x by the bit string corresponding to the C of x using the module 2 division. Subtract the remainder which is always R or fewer bits from the string corresponding to x power R M of x. Using the module 2 subtraction, addition and subtraction are the same in module 2. The result is the checksum frame to be transmitted called the polynomial M of x. Okay. Here the CRC calculation using the long division method. By using the long division method, the CRC value will be calculated by using the dividend and divisor value. Okay. The properties of generator polynomial. The properties means let P of x means polynomial of x value represent the sent P of x plus E of x is received string where A of 1 in E of x represent that in the corresponding position in P of x, the message, the bit is flipped. We know that P of x divided by C of x leaves a remainder of 0. But if C of x divided by E of x divided by C of x leaves the remainder of 0, either E of x will be 0 or C of x is factorial of E of x. Then based upon the what is the property they are telling means based upon the remainder value should be 0. If it is not 0 means want to do the cycling process. Another time process, cycling process will be performed in the CRC dividend by using the dividend and divisor process. Okay. In general, it is possible to prove the following types of errors can be detected by a C of x with the stated properties. If it is a single bit error means based upon the it is a non-zero coefficient. If it is a double bits error means based upon single bit error means what? Either 1 is assigned as 0 or 0 is assigned as 1. That is a single bit error. If I am transmitting the data is for example we can say the data I am transmitting from sender to is 4 ones. Okay. The receiver if I am that is a original bit is 4 ones. I am translating the 1 bit error. 1 bit error means what? Instead of 4 ones, I am changing the 3 ones and 1 0 in the particular bits. Okay. In that will be transmitted means that will shows the error. This is a single bit error. Single bit error means only 1 bit has changed from 0 to 1 or 1 to 0. Okay. After it shows it comes under the single bit error. Double bit error means 1 or 2 birds will be changed as 1 to 0 or 0 to 1. Okay. Any odd number of error as long as C of x contains a factor of x plus 1. Any odd number means based upon the we are using the either odd parity or even parity. Based upon that only, based on that error will be assigned in the C of x that will be added to x value. Okay. Any burst error that is a sequence of consecutive error bits for which the length of the burst is less than k bits. Is less than k bits means what? More burst error of larger than the k bits. More burst error means what? If more than if you assigning single bit error means it's assigned as a single bit error. Double bit and then more than one bits means it is assigned as a burst error. More than 2 bits or more than 1 bit will be assigned as a burst error. Okay, burst error means what? More than 1 bit will be changed from 0s to 1 or 1 to 0. It is called as a burst error. Okay, it's larger than the k bits. K bits means what? Compared to the n number of bits will be used from sender to receiver. That is a larger than the k bits can also be detected. Okay, these are the about the topic we discussed in the CRC. Next, reliable transmission. Reliable transmission means what? Based upon the time duration, within a time duration, the data will be transmitted from sender to receiver. For example, within a time duration means what? I am sending, for example, I am sending a mail to one person, or I am sending a message to another person. Within a time duration, it will show the time. For example, it will show the 10 seconds. Within a seconds, the message is not transmitted to a particular receiver means it will tell the timeout, or it will show the time error. The message is not transmitted. Okay, within a particular short duration, the message will be transmitted from sender to receiver, and then also within a particular duration, the acknowledgement will be received from receiver to sender that a particular message has received for that acknowledgement. Based upon that is the reliable transmission. Okay, CRC is used to detect errors. Okay, at the time of transmission, by using the CRC only, the error will be detected. Okay, most error codes are strong enough to correct errors. Most error codes means based upon the error correcting techniques only, error detection techniques only, the more codes, error codes will be corrected. Okay, the overhead is typically too high. Correct frames must be discarded. Okay, you are in the data link layer. What you are doing now, based upon the frames only transmitted from sender to receiver. If the corrupted frame, if 5 frames are transmitting from sender to receiver, in that only 1 frame is assigned as a corrupted frame. If one at the time of transmission, 1 frame is corrupted means that particular frame will be discarded. Okay, based upon the receiver request only, the particular frame will be retransmitted from the sender to receiver. Will acknowledgement the particular message as received. This is the acknowledgement. Okay, an acknowledgement is a small control frame that a protocol sends back to its peers that a message received the frame earlier frame. Okay, up to for example, we can say 1 to 5 frames are sending from sender to receiver. Receiver at the time of transmission, the receiver will send the acknowledgement as frame 1 as received, frame 2 as received. Based upon for each and every frame, the receiver will send the acknowledgement to the sender. Okay, the control frame is a frame with a header only, no data. Okay, control frame means what? Based upon the transmission time or transmission delay, based upon the control frame will be transmitted with the help of the header only. No data will be assigned in the particular header. Okay, next, the recipient of the acknowledgement indicates to the sender of the original frame that its frame was successfully delivered. Okay, based upon that acknowledgement of particular receiver only, the sender will assign the particular frame as received by the receiver. Okay, If the sender does not receive any acknowledgement after the reasonable amount of time, it will then retransmit the original frame. I already told no. If the particular message or frame is not received by the receiver, means he won't send the particular acknowledgement to the sender. Based upon that, the sender will retransmit the particular frame to the another time to the receiver. Okay, the action of waiting a reasonable amount of time is called as timeout. Okay, the reasonable for amount of time means I already don't know. Based upon the time duration, it will allocate the time duration to send the message from sender to receiver. Likewise, same and for acknowledgement also, it will wait for particular duration of time. After the particular duration of time only, the particular frame will be retransmitted from sender to receiver. Okay, the general strategy of using the acknowledgement and time out to implement the reliable delivery in sometimes called as automatic repeat request. Automatic repeat request means in the sense automatically the within a time duration exceeds means what? Automatically the retransmission will be transmitted from sender to receiver. Same wise from acknowledgement also, if acknowledgement will not be sent means the acknowledgement will be retransmitted from the receiver to sender automatically. That is a automatic repeat request. Okay, up to this reliable transmission based upon the will be performed based upon the timeout and the acknowledgement. That is a reliable transmission. Okay, up to this we have any doubt? We have discussed about two topics, reliable transmission and then CRC. Next we have move on to stop and wait protocol. This is there are two types of protocol used in the data link layer. First one is stop and wait protocol. Second one is sliding window protocol. Okay, till this you have any this up to this these are the services up to the top in syllabus. Services of data link layer. Up to this it's over. Reliable transmission up to reliable transmission services of data link layer is over. Okay, then we are going to protocol, data link layer protocol. Protocol in the sense what are the rules to be followed in the data link layer. Okay, data link, this is a topic we are going to discuss about the data link layer protocol. Okay, here in the data link layer, see A is assigned as a one diagram, A, B, C. There are 4 stages how the frame is transmitted from sender to receiver. First one is the acknowledgement is received before the timer expires. Okay, the particular duration between the sender, first of all, sender will transmit the frame to the receiver. Based upon the receiver will transmit the acknowledgement within a time duration period. Okay, for example, I am assigning the 5 minutes time duration. Within the time duration, the particular frame will reach the particular destination receiver, and then receiver also will send the acknowledgement to the sender. This is within a 5 minutes time. These two process if completed means that is the acknowledgement received before the timer expires. That is the first stage diagram. Acknowledgement is received before the timer expires. Okay, B, the original frame is lost. Original frame is lost means what? The data frame is sent by the sender, and then within a particular duration, within at a time of transmission itself, the frame has lost. After that particular time duration, the retransmission of a particular frame will be done from the sender to receiver. Okay, at the time retransmission will be done in the sender, and then acknowledgement will be received from the receiver. This is the second stage. Okay, this is the second stage. What is the second stage means the original frame is lost. Okay, based upon the original frame lost, the acknowledgement will be not received. Based upon that, retransmission process will be performed in the sender side. Third one, acknowledgement is lost. Okay, acknowledgement lost means what? Within a time duration, the sender has sent the data frame. Within a time duration, within a time out duration, the acknowledgement is not received by the sender. Receiver has sent the acknowledgement. Due to corruption or due to loss of acknowledgement, the the particular acknowledgement is not received by the sender. So another time, what is the sender is doing? Sender is retransmitting the same frame to the receiver. Okay, and then within a time duration, the acknowledgement as received by the sender. Okay, this is a third stage, is the acknowledgement is lost. Okay, this is a fourth stage, is the timeout fires too soon. Timeout means what? After the time, I am telling no 5 minutes time, within a 5 minutes, the message or acknowledgement is not received by the sender, but based upon that, before itself, the frame will be retransmitted from the sender. Okay, the timeout fires too soon means what? Within a timeout period, the acknowledgement was not received within a seconds, so the sender will retransmit the particular frame to the receiver, and then acknowledgement will be received by the sender. Okay, these are the four stages, four scenarios used in the stop and wait algorithm. First one is acknowledgement is received before the time expires. Acknowledgement is received before the time expires. Second one, the original frame is lost. Original frame will be, which is transmitted from sender, is lost. Third one, acknowledgement is lost. Whichever the receiver send the acknowledgement to the particular frame, that will be lost. That is the third stage. Fourth one, the timeout fires soon. Based upon the timeout period, the acknowledgement is not received means the particular frame will be retransmitted from the sender. These are the four stages of stop and wait algorithm. You have any doubt? This will be asked any 2 mark questions or any 8 mark questions. This stop and wait protocol and then sliding window protocol is an important question. Okay, you have any doubt? This 4 stages of stop and wait algorithm. Nobody is responding.
Yes, sir.
If you have any doubt, we can proceed.
Yes, sir.
Okay. Okay. Next, in stop and wait algorithm, there is a delay. Okay, based upon that, see, if you are previous diagram, we are transmitting only one frame. Okay, based upon that, one frame is transmitted. For that one frame, the acknowledgement is received, and then frame has lost, acknowledgement lost, and then acknowledgement has delayed, receiving delay. Likewise, only one frame is transmitted. In this example, see, only stop and wait 1 bit sequence for equal number of times. Okay, the sender is transmitting n number of time duration is maximum limited is there. Based upon that, frame 1 will be transmitted from frame 0 is transmitted from sender, and then for that frame 0, the receiver will send the acknowledgement for acknowledgement 0. After that acknowledgement 0 only, frame 1 will be transmitted. Okay, another time frame 1 will be transmitted. After receiving the acknowledgement for frame 1, then likewise frame 2 or again one frame 0, like that continuously the transmission between the sender and receiver will be transmitting the frame. Okay, if the acknowledgement is lost, delayed in arriving means the sender timeouts and retransmit the original frame, but the receiver will think that the next frame, since it has correctly received the acknowledgement for the first frame. As a result, duplicate copies of frame will be delivered. Duplicate copies means what? If the acknowledgement is not received by the sender means the duplicate same frame 0, here in this diagram again frame 0 is transmitting. Based upon that, if acknowledgement is not received by the sender means that duplication will be received sent by the sender. How to solve this? How to solve it means use 1 bit sequence number 0 or 1. Based upon the sequence number only, the data will be transmitted from from sender to receiver. Here n number of, when the sender transmit frame 0, the receiver can determine it is seeing the second copy of frame 0 rather the first copy of frame 1. Okay, the receiver still acknowledgement in the case of first frame acknowledgement is lost. Okay, based upon the acknowledgement lost for first frame, it will send the acknowledgement to the sender. Okay, okay, the sender has only the one outstanding frame on the link at the time. This may be far below the link capacity. Consider a 1.5 megabits per second with 45 milliseconds RTT. RTT means what? Based upon the time duration that bits link established between the sender and receiver in the delay time of time duration within the time duration of time. Okay, the link has been established. The one second. Okay, sorry for interruption. Okay, here this considered based upon the sender can send a one frame to the RTT. RTT means retransmission technique, and assuming the frame size is 1 KB. Frame size will be maximum 1 KB will be the frame size. Maximum sending rate will be bits per frame divided by time per frame. Totally 1024 equal to 1024 is a what is a 1 bit bits equal to 1024 divided by 8 bits. 8 bytes will be finally the transmission will be in the 1 bits will be transmitted 182 kbps. Link will be established between sender and receiver is in the speed of 182 kbps. To use the link fully, the sender should transmit the 8 frames before having the wait for acknowledgement. In the time of transmission, the data will be transmitted from sender to receiver. At the time, the 8 frames will be transmitted from sender to receiver. Then before receiving the acknowledgement, the transmission will be transmitted from sender to receiver. For this, we will show this diagram. See here, 3 frames are transmitted from sender to receiver. That equivalent to 3 frames, the receiver will send the acknowledgement to the sender. Okay, based upon the acknowledgement only, the sender will transmit the frame to another size. SWS means what? Sender size window. Last acknowledgement received. LAR means based upon the I am sending frame 1 sequence number will be generated from sender to receiver transmission. First of all, based upon the sequence number only, the data will be transmitted from sender to receiver. We can assign if frame 1, frame 2, frame 3 are sending from sender, 3 frames are sended. Based upon that, acknowledgement received. LAR means what? Last acknowledgement received. For same frame 0 acknowledgement, frame 1 acknowledgement, and then frame 2 acknowledgement. After that only, the last frame will be sent to the by the sender. Okay, last frame sent means what? Sequence number of last frame will be transmitted from sender to receiver. Okay, this n number of frames will be transmitted simultaneously with the help of the sequence number. Okay, up to this stop and wait previously over. This is a sliding window control. Sliding window protocol only. Based upon this time, the slide sending window size will be assigned. Last acknowledgement received, last frame will be assigned in the with the help of sequence number only. Sliding window protocol will be performed. Previously, stop and wait only based upon the each and every frame acknowledgement received. and then in sliding window simultaneously data will be transmitted. After that only the acknowledgement will be received for each and every frame. Bulk of frames will be transmitted simultaneously. Okay, this is a frame format. This is a frame where the sender also maintains the following invariant. Invariant means what? Based upon the LFS last frame sent, last acknowledgement received, and then based upon the SWS means what? SWS sending window size. Whatever the sending window size will be based upon the window size, the sender will be assigned the frame format for between the sender and receiver. When the acknowledgement arrives means the sender will move the LAR to right. There will be allowing the sender to transmit the another frame. For example, here what is the indication of LAR indication? Next 2 bits the LR indication is there. After receiving the acknowledgement from the receiver means the LAR bit will be transmitted to next level. Okay, same likewise last frame size is last frame bit. This is a LFS means based upon the there will be a 7 bits frame. Based on 7th bit will be assigned as a last frame bit. Okay, when an acknowledgement arrives means based upon that only the sender will retransmit or transmit will be transmitted within a time limit period. Okay, also the sender associate a time frame of each frame it transmit the timer expressed before the acknowledgement is received. Okay, here main process here sliding window means it will be showed in the buffer process. It will show buffer up the single window size frame. Single window size frame means it will be show buffered with the help of sliding window protocol technique. Okay, next the receiver maintains 3 variables. That is maintained in the sender side. The receiver also will maintain the 3 variables. What are the variables means receiving window size which is upper bound on the number of out of order frames that is receiver will willing to accept. Okay, for example the sender is sending 5 frames, the receiver window size is only 3. Window size of the receiver means 3 only, means the receiver can able to accept only the 3 frames only. Except the 3 frame size, the receiver cannot able to accept the particular frame size. Okay, largest acceptable frame is what? Sequence number of the largest acceptable frame based upon the here for a frames are 1 to 5 means largest acceptable frame means 5 is accepted. Based upon that only their window size will be 3 means based upon 3, 5, 4, 3 only accepted by the receiver. Remaining and all it will be discarded. Okay, last frame received. Last frame means whatever frame received by the receiver which is sent by the sender is called as last frame received. That is LFR, the sequence number of last frame received. The receiver also maintain invariant as LAF minus LFR less than or equal to receiver window size. Previously we have seen this is in this example. See here what is a LFS minus LAR less than or equal to sender window size. Same way here receiver window size. Okay, when a frame with a sequence number arrives which does not receiver do. Okay, if a sequence number is not there with the help of with the ideal sequence number, the sender transmit the data means the particular frame will be discarded by the receiver. Okay, if the sequence number will not match the LFR or greater than LAF means the particular sequence number will be discarded. Okay, same way the LFS less than sequence number and then less than LAF means the particular frame will be accepted by the receiver. Based upon that the receiver will send an acknowledgement for the particular frame. Okay, if based upon that only the acknowledgement will be sent to the sender. let sequence number to acknowledgement. The sequence number will be generated to adjacent frames, which is equivalent to number of frames received by the receiver. Okay, the receiver will set the LFR equal to sequence number to acknowledgement and then adjacent. And then here LAF equal to LFR plus receiver window size. Receiver LAF equal to receiver window size plus LFR. Okay. Same way here, for example, we suppose we are using the example as LFR equal to 5, RWS receiver window size is 4. If the acknowledgement receiver that the receiver sent for sequence 5 means the LAF equal to 9. The frame, if frame 7 and 8 receives it, they will be in the buffered because they are within a receiver window. But no acknowledgement will be sent since frame 6 is yet to arrive. Okay, based upon the acknowledgement will be received by the sender in the sequence order. After receiving of 1 only, 2 will be able to receive. After receiving of 2 only, 3 can be able to receive the acknowledgement. Then after receiving of 4 only, 5 can be able to receive the acknowledgement from the receiver. Okay, here frame 7 and 8 is out of order. Frame 6 arrives. It is late because it is lost first time. Okay, it is a retransmitter process is there performed in the sender side. Now the receiver acknowledgement for 8 finally it will goes to 8 process. Okay, this is the issues as faced in the sliding window. When the timeout occurs means based upon the transmission time will be decreases. When the packet loss occurs means no longer keeping the pipe full. Okay, negative acknowledgement. This is called as how to improve the sliding window protocol means by sending the negative acknowledgement. Negative acknowledgements that a particular frame is not received by the receiver. Okay, additional acknowledgement to improve means additional acknowledgement can be sent by the receiver to the sender. Selective acknowledgement, if n number of frames are sent, only this number of frames are selectively acknowledgement. This number of frames only received by the receiver, for that is called as a selective acknowledgement. And then negative acknowledgement in the sense the receiver sends the NAK negative acknowledgement for frame 6 and frame 7 arrives in a previous example. However, this is mandatory since sender will time out, the process will be received by the receiver. The duplication process will be that the frame will be lost. Okay, and then selective acknowledgement means what? Based upon the selective acknowledgement will be sent by the receiver to sender. Okay, based upon that how to select the window size. Select the window size means delay into bandwidth, total bandwidth of the bandwidth into delay, how much delay, time duration delay equal to into bandwidth. The same way sender window size will be computed. Same way receiver window size will be used in the two common setting. RWS means write window size equal to 1. No buffer will be stored in the frame lost. Okay, in that RWS equal to SWS, receiver window size will be equal to sender window size. Okay, next is a finite issues. It's a finite sequence number. How to distinguish between the incarnate and the same sequence number. If for example, if the same sequence number will be transmitted from sender to receiver means based upon that the particular frame will be discarded by the receiver due to some repetition of same frame number or same delay in the particular duration of time. Okay, next this for example we are having the 8 sequence number 0 to 7. Okay, here write receiver window size equal to sender window size equal to 7. Okay, based upon the window size is 7, and then we are sending the 8 sequence number. Okay, here the sender sends the 0 to 6 because the sender window size is 7, so the sender will send the frame from 0 to 6. Okay, the receiver will receives the 0 to 6. The receiver acknowledgement sends the 0 to 6. Okay, because the window size is 7, so based upon that only, the only 7 bits will be 7 sequence number will be generated between the sender and receiver. If the acknowledgement will be received by, if acknowledgement is not received by the sender, means based upon that the sender will retransmit between the 0 to 6 node. Okay, and then the receiver will expecting the acknowledgement from the sender. To avoid this, if RWS equal to SWS, SWS less than maximum sequence number plus 1 divided by 2 serves different 3 roles. There are 3 different roles, means first one reliable, second one preserve the order, third one frame control. Based upon these 3 types of roles only, the data transmitted between the frames will be transmitted between the sender and receiver with the help of acknowledgement. And then if the particular receiver cannot be able to receive the particular frame, means it will not be send the acknowledgement to the sender. Based upon that, the sender will retransmit the particular frame to the receiver. Up to this sliding window protocol topic is over. Okay, HDLC and point to point we will discuss in next class. Okay, we have any doubt till the stop and wait protocol and sliding window protocol. These 2 types will be used in the data link layer protocols. If you have any doubt? We can wind up the session, huh? Okay. Do you have any doubt? The topics, 2
No, sir.
topics. Okay. Okay, we can wind up the session. Okay, thank you to all.
Thank you, sir.
Thank you, sir.